Welcome. In this lecture, I'm just going to go through some of the very basics of like kind of the notation and how we talk about vectors because we're going to need them for gradients, which are going to kind of give us like the direction that a function is changing the fastest. I know this is a little bit like it's just notation. You can do it. I know it's a little notation always feels a little overwhelming and confusing at first. This is true even for advanced mathematicians of every level and so on. So don't get intimidated. You can do it. It just like it always does takes a little bit of practice and a few deep breaths and kind of just sorting things out. So here we go. So let's first look at in 2 dimensions. So in 2 dimensions, what's the how do we talk about vectors? So a vector is going to have, you've got to figure out, just like a point in R2, you need to figure out, how far you go in the horizontal direction and then how far you go in the vertical direction. And this really is going to correspond exactly to that. And I'll even kind of show you. In fact, actually, maybe I'll show you this part first, which is that we do this by breaking it into adding together 2 kind of vectors, little vectors. So we have this vector here, okay, which ends at 1. Okay, so this is the vector. We write this vector as I equals 1, 0. Okay, and then we have this other vector that's going to end at 1 in this direction, and this is going to be J. Okay, so this is going to be J equals 0, 1. And then all I need to know if I want to be able to add these together to get to anywhere in here is I need to know like how big I'm going to scale them and then whether maybe I'm flipping it on the other side or something. Okay, so we have V1. So that's the scalar that's telling me how big I'm going to scale this by or multiply it by, and then that vector I. Okay, so this gives me the distance in the x direction. So this is the distance in the x direction, and you wouldn't be surprised that like it goes backwards if sign negative. So backward, like it points in that direction instead if there's a minus in front of it. Okay, so that's kind of the first piece of that, and then we're going to add that together with we're going to have how far we go in the second direction. Oops, this should be a 2. So we have V2. Oops, that's not what I wanted at all there. I'm not sure why these things happen. Okay, so then we put this is what I want to put was a J like that, right? Because I'm multiplying this direction by J. Okay, so this is going to tell me the distance in the y direction. And again, not surprising at all that I'm going down if there's a minus in front of it. Okay, great. So let's kind of look at with these pieces put together. I get my vector V. I can break it into the 2 parts. So I have, oops, this is this one. Right, so I have, this is V1I, and then I add to it, right? We always add to them by putting them like nose to tail or whatever, that I start the next one here and I go up, and this is how I add vectors, right? Like I add them like that. And then this is giving me V2J. Okay, so here's some kind of other notation, which is good to know. So let's put our other notation here. Which is just another way we like to write it. We sometimes like to write our vectors like this, where I put the V1 in here and the V2 in here. And then the last thing that it's good to know is what is the length of this vector that I've been drawing here. So this length is going to be, so this length of this vector is equal to the square root of, so we're going to have a v1 here, and we're going to have a v2 here, and we're going to square them and add them together. And if you think about this, this is exactly the Pythagorean theorem, right? I'm taking this length squared plus this length squared equals this length squared. The square root is because I said this length squared. Okay, so you can almost guess what's going to happen in 3 dimensions now, kind of based on what happens in 2 dimensions. So let's go through that really quickly. So in 3 dimensions, so we're going to have a vector. Now we're going to want to write it. So let's first draw. I think it helped a little bit to actually draw the picture first before we write it like that. So we've got an x direction, a y direction, and a z direction. And then I've got, right, if I go, and then now I want to be able to go 1 in each direction. I usually tell people to think of this like you're in the corner of a room, and, you know, you've got, you know, going one direction in the room or the other direction in the room and then going up. But if you look in the corner of the room, you can almost like use it to say, well, I start in the corner of the room and then I take 3 steps in this direction, and then I take 3 steps in, or 4 steps in that direction, and then I go 2 up, right? And this is how it can help to think about this. So the one that goes in the x direction here is I. So this is I, which now has to have 3 coordinates. So it looks like this. And then my j, like this. So this is j equals 0, 1, 0. And then I have my k. Should put down this rag, my cleaning device when I make mistakes. Okay, and then my k is going to be k equals, where do I want to put it? I'll put it over here. It's an okay place to put it. K equals 0, 0, 1. Okay, so now I want to talk about how far I can go in each of those directions. So I get v is going to equal, and then I want to take, so from this direction, right, I need to figure out how to scale that one, and I go v1 times I was checking whether I made a mistake over there. Did an okay job, surprisingly. And then v2 times j. It was only the v2 that I, you know, the j there that I messed up, not the I. And then I have v3 times k. So those are kind of how far do I go in the x direction, the y direction, and the j direction. I'm not going to draw the picture of trying to add these together because I've tried to do it before and I think it's a little hard on a surface like this. But you can imagine that it's kind of like you do nose to tail, and then you've got to have another one that's sticking straight out at you, maybe, and then you have to get to the end point of that, and that one sticking out is your v3 times k. Okay. So our other notation, we'll put here. So our other notation here, it's going to be, so now it's just this vector where I go like this. So I have v1, v2, and v3. And then I have the last part that I want to do, just like I want to do over there, is to do the length. And so my length is going to equal, so the length of this vector, like this, it's exactly the same except I add the third component also. So I'm adding together the 3 components and squaring each of them. So I add together my v1, my v2, and my v3. Okay. So this is just a little bit, I know this is like a little bit of notation. It's ways to kind of break apart these vectors. It ends up being useful. It's just another thing to get useful. It's like one of these things you get used to it, and then it turns out to be really useful and helpful. So it's worth getting used to, but not getting intimidated by at the start. Okay, so I hope that made some sense. and I will see you in the next lecture.